I like the fact that your papers, some of them are long because they have to be long with lots of explanation, and some of them are really short, only 1 or 2 pages long, and they have an idea that you discuss almost like a light bite-sized chunk of information, which is really good when you're trying to learn about lighting. And there's a couple that spring to mind. One of them was Discomfort, Glare and Visual Distraction, in which you discuss it and then really say that they're 2 aspects of the same thing. I like this no waffle approach. It's lovely succinct work. Would you like to say something about that paper that you did?
2 things, yes. One is that it started with the BRE expression for discomfort glare, luminance to the power of 1.8, background times background brightness, times omega.
We'll show the formula up.
I see, right, okay. Mm-hmm. Yeah. Because that was what was
known at the time.
Yes, that's right. Well, now, if instead of taking that, you take the CIE formula, which is the luminance of the source squared times omega divided by LB, it's much better because you don't have to use all the arguments about apparent brightness and so forth, which is open to dispute. You can go straight from that to Piper's law, and it all drops out in one sentence, just about.
Yes. Yes.
That's one thing to say about it. So if I was writing it today, that's what I would say, obviously. The other thing is, it was a controversial paper. Professor Hopkinson hated it, and
why did he hate it?
Well, he thought it was wrong. Full stop, he thought it was wrong.
He thought the 2 things were distinct.
Yes, mm-hmm. And most people do. There's no question about that. And it's unkind to say this, but if you take it, if that paper's right, then there's no need to have done all the research that he did do on glare. You could simply have produced a glare expression.
If I can quote you.
Yes, okay.
Mm-hmm. In your conclusion, you write, just as an acoustician defines noise as unwanted sound, so a lighting designer engineer can think of discomfort glare as unwanted light. But rather than this just being a phrase you've plucked out of the air, you've proved it by your mathematical argument.
I haven't proved it. No, you have to be very careful.
You've shown it. What I mean to say, you've shown it
mm-hmm.
by using the known formula and combining them.
Yes, I've shown it. I've shown that it's plausible, but it doesn't follow that if 2 phenomena follow the same formula, that they're the same. That they're the same thing. It doesn't follow, and I didn't claim that it followed. I think there's something that
what it does, it gives a plausibility to your argument.
It's plausible. Yes, yeah. I still think it's plausible. Yes.
Yes, and that's what I like about some of these short papers that you do. They concentrate on one thing and one thing only, and justify as best they can what your thoughts were.
Well, I'm glad you like it. Yes, but a lot of people hate it. So it's.
But what's their argument for not liking it? That's what I'm not clear about. Because it seems.
Well, you see, anybody with another explanation for discomfort glare, say pupil oscillation or pupil size, or the Fourier business about analysing the luminance pattern of the field, I mean, all those people will say, well, I mean, anybody who's got a different theory is going to dislike this theory because it bypasses their theories. I mean, that's human nature. I mean, I'm not saying that people are biased against it, but people aren't biased against it. Some people accept it, but
it seems plausible to people designing lighting schemes.
Well, I find it plausible. I mean, I think it's ridiculous to look somewhere else.
If I can turn to another short paper you did, which is one which was called Cylindrical or Scalar Illumination.
Yes.
Now, before you answer, coming back very much into fashion is the use of cylindrical illuminance as a measure of whether a task can be done, because the task is three-dimensional. I just wondered, in it you say that cylindrical illuminance and scalar illuminance are very good measures, and they're quite similar in the sense that they give similar kind of results, except when you've got a room that's got a blackened ceiling and very narrow beam downlights, when you would only use scalar illumination. But what are your thoughts now about the arguments of not using horizontal illuminance for tasks over using cylindrical and scalar illuminance?
Well, I mean, there isn't a general answer, is there? I mean, if you're trying to read that print, what you're interested in is the horizontal illuminance. If we're looking at each other, then probably cylindrical is as good as anything. And if you're assessing the general brightness of a room, scalar has probably an advantage. I mean, I wouldn't be dogmatic about this.
Well, you wrote another paper about how to estimate scalar illuminance.
What was this one?
You wrote one, I was reading it the other day, about ways, if you're a lighting designer, of estimating what the scalar illuminance of the space is.
Yes, I think I remember that one, yes.
So what would you conclude now that you've been thinking about this for so many years?
Well, I mean, that's a perfectly valid paper. That was a perfectly valid paper. Mind you, it does assume that you're using the Lumen method, but I mean, if you're using the Lumen method, I mean, if you're using a table of coefficients of utilization factors, then there's nothing to stop you just taking out a pen and marking which combinations of room index and reflectance for a given fitting give you a reasonable vector scalar ratio or whatever. I mean, it's...
In fact, there's a lovely piece of work you did on interreflection charts.
Yes, the luminaire domain thing, yes. Mm-hmm.
Yes. Would you like to explain your thoughts on it? What the way I see it is that if you had some task and you want to light it, by working out different ratios of ceiling to wall luminance, it would infer what the modelling might look like of the task.
Well, I mean, yes, one of the things it shows is that in a given room, the two installations which give the same average vector scalar ratio will also give the same wall-to-task illuminance ratio. That's an interesting result for what it's worth. It's an interesting result. But
because the idea of modelling is coming back more and more in the ideas of young people doing lighting design. And what's lovely about your work you've done on cylindrical illuminance, scalar illuminance, and these ratios is you've been writing about this for 40 years, and it's become de rigueur now. And are you pleased about that?
Well, what happened to the Luminaire domain thing, you see, is that it was based on the British zonal system, which I still think is a useful system, not for glare prediction, but for looking at the distribution of light in a room. I mean, it's,
the BZ classifications for
yes,
fittings
that's
that we
right.
used to have.
I mean, I think it was killed off, you see, by the lighting manufacturers who, you see, if you use a BZ classification, then you very easily can compare a Thorn fitting with a Phillips fitting and so forth. There's no problem. But if you don't use the BZ classification, then it's less easy to compare a Thorn fitting with a Phillips fitting or whatever. And so it suited all the lighting manufacturers to abandon the BZ system. Now, they were quite right to abandon it for glare. It was discredited, there's no question about that. But it wasn't discredited for all these other purposes. But the fact that it was discredited meant that nobody uses Luminaire domain thinking anymore.
Well, throughout your papers, you look at simple ways to circumnavigate doing complicated calculations.
That's right. Well, I think I am a visual person rather than a verbal person, and that I think is reflected in that. Yes, that's right.
We're going to talk about some examples a bit later.
Yes, well, of course, computers have made all that rather redundant. It's much simpler nowadays to use a computer than to use a graphical method. That's
I sometimes wonder if you lose something, people that only use computers, they lose something by not doing these things.
What you lose is, you see, if you have something which is a diagram, you can understand the diagram as a whole object. Yes, that's right. Whereas with a computer program, especially if you haven't written it yourself, you don't know really, you don't have the same vivid impression of what that's doing.
Yes. You can't feel the answer.
That's right.
Yes. Does it worry you that some students use software and never hand calculate anything, really? Does that worry you?
Does it worry me? Not a lot, but I think you should at least have some rules of thumb. Well, I'm sure you should.
What to know when it's wrong.
Yeah, that's right, yes.
Yes. One of the things that I'd like your opinion on, when I used to do photometry, we used to make an eye table, goniometry, we used to make an eye table, and we would draw isocandela diagrams. And at a glance, you can see an analogue drawing of what this luminaire might do.
Yes, that's right.
But now, because people use software and all the eye tables are encrypted, so it's very hard to actually get to the raw data. I think that it's harder for younger designers to appreciate what it will do until they've just tried it in a piece of software. Do you think that's a fair?
Yes, it is. I mean, and it's not just. I mean, it's true of polar curves as well. That you don't see polar curves the way you used to. Yes,
or only the peak ones if you're lucky. Yeah. There was another paper that you did, was called Discomfort, Glare and Visual Distraction. And if I can just quote the first paragraph of that. It is customary to draw a distinction between the distraction caused by a light source and the discomfort glare which it produces, the latter being variously attributed to local overstimulation of the retina, to neutral interaction, and to the muscular response to fluctuations in pupil diameter. Whether it's possible to distinguish so clearly between discomfort and distraction is a moot point.
Can I see what I wrote?
Yeah.
Yes, that's right. That sounds enough. Mm-hmm.
Okay. The another topic that you did a lot of work on, I remember 2 years ago we celebrated 100 years of the Munsell system.
Mm-hmm.
And I had to give a talk about Munsell, and we did a whole evening
Yes,
on colour in general, and we had lots of speakers. And you've done a lot of work applying the Munsell system, using the ideas of colour constancy. And in fact, you consider whether the Munsell system might be employed to describe how the appearance of a surface might be used to describe how the appearance of a surface is affected by changes in the lighting. It should also fit Waldrom's design appearance techniques. Design appearance techniques were a big thing. What was your relation with that?
Oh, I was inspired by it, yes. I mean, there's no doubt. His his 1953 paper was published in 1954, so I don't know which date you want to give it. That was a turning point, not only for me, but for, a turning point in thinking about lighting, yes, for a lot of people.
Would you say the point was to look at the thing you're trying to light and look at how that was lit as opposed to everything else that came from it? How do you describe the premise behind it?
Well, you see, before that paper, basically lighting design consisted of the Lumen method. I mean, we called it the Lumen bash, and I mean, that's all you did. And afterwards, you see, even that was in the 1950s. There wasn't any glare index system. I mean, there was research on glare, but there wasn't an IS glare index system or anything comparable with that. So starting from Waldrom's paper, a whole lot of things developed. An interest in modelling, an interest in texture, an interest in glare, and an interest in not just the working plane, but the whole, the ceiling, the walls, the emphasis on different parts of the environment. I mean, it's all hinted at in that paper.
Yes. And constancy being the fact.
Oh, constancy wasn't mentioned. That's right.
Yeah.
Constancy. I think constancy is never sort of caught on as a lighting criterion.
But it's very noticeable. If you say that if you got a green leaf and you light it twice as much, it's still a green leaf.
Oh yes, I don't need convincing that.
Yeah, but I like that.
Mm-hmm.
You've got a way of writing analogies that people pick up on in your work.
Well, I'm glad you like it. Kit Cuttle is just rediscovering it, I think, but nobody else seems to have taken it up as.
But the way you describe hue, value, and chroma,
Mm-hmm.
and apply it to a real lighting task in the thing, it's quite profound, really. As opposed to just a way of defining a colour, you've used it as a useful tool when you're designing.
Well, I wonder. I mean, for some purposes it is. You probably haven't spotted a paper I gave at a national lighting conference. Well, really about the appearance of a window wall, chiefly, which I think. I mean that's a good example of.
I have read one, and you were talking about how when you've got daylight coming in and mixing with artificial light, it reduces things like flicker. And you give 4 other examples of things that are improved by mixing them together.
No, I don't think that's the paper though. That was but I mean I don't think that's the same paper. Yes, there was one which suggested that certain anomalies in photometry were penalised daylight, and I think that's pretty much accepted now. Not always for the same reasons as I gave, but yes.
Well, one of the things I really like about the work you've done is you've produced practical things which have helped people to do lighting design. Like things like the grease spot, the sundial that you rediscovered.
Oh dear.
Even before computers, you were doing stereographic ways of doing floodlighting as a tool. I mean, perhaps you wouldn't need to do it now so much with computers, but nevertheless, it showed people how to understand what they were doing in 3D, and I think perhaps your most famous one is perhaps the pepper pot diagram used in daylighting.
Mm-hmm.
Could you talk us through some of these things that you've done which have been so useful?
Well, what I did produce in Pilkington's was this whole package of diagrams. You've not seen these. They're lovely for prediction of sunlight penetration, mostly sunlight penetration, but you can see these for modelling and different vector scalar ratios, and also the pepper pot diagrams, as you saw, well, there's the pepper pot.
Yeah, well, it made it possible for any new person coming into lighting to be able to calculate the daylight factor in a building.
Well, the great thing about it is that you see we were using mnemonic projection both for daylight factors, but also for sunlight, and also, of course, for analysing the view through the window, and these are this thing should be a holistic. I mean, what we were looking for was a holistic way of designing windows. Now I think I've gone beyond that with the paper that you've seen about the sequence for daylight for window design.
Yes.
But at the time, this was done in the 1960s. This was a big advance.
Yes.
And Pilkington's issued these, and they distributed them among architects and so forth. So it was a great blessing when I started teaching that I had all these things ready to share. So this particular one is a sundial. Yes. So you put your little gnome on here, and that's 3 meters is its height, and this tells you the path of the shadow of the gnome on. Here, obviously, it's at midsummer, July, August, September, the equinox, when the sun travels in a straight line. October, November, December, the winter solstice. This direction, of course, is due north, so this would be noon when the shadow's due north, 1 o'clock, 2 o'clock, 3 o'clock, 4 o'clock, 5 o'clock, 6 o'clock, and so forth. This is latitude 42,
Yes.
and then, oopsie, we've got these all sorts of other latitudes. So that's 40.
42 being our latitude.
No, ours is about 50. Isn't it?
51, that's right.
51, yeah.
So Pilkington used to send these out to help architects,
That's right, yes.
and you formulated them.
Well, yes. Again, so none of this is really original. You can point to other people. Well, obviously, Sundial isn't original, but
At a glance, you can see everything about it.
yes. Well, this is the one for 50 degrees, which would be right for Hastings, roughly right for Hastings. It's the same pattern, but you see, the great thing is that if you want to know how a vertical sundial would be, say facing due south, you just take the one for 40 degrees and hold it vertically. And that's the one for Hastings, facing due south. This is still noon, 1 o'clock, sorry, the other way round, 1 o'clock, 2 o'clock, 3 o'clock, 4 o'clock. And you see, the advantage of this is that if you turn it upside down like that and put your eye 3 centimetres from that point, then this tells you, if you're facing due south, where the sun is going to be at different times of day, at different times of year. So it's going to be right up there in the summer, but down here in the winter.
So you could go to a site long before a building was built and imagine it.
That's right, yes.
And so this was the precursor to this.
That's right, yes. Sequence for window design, yes. Yes, that's right. It's you see, before this came along, the package was sunlight didn't count, you know. And, I mean, there was never. I mean, in the 1950s, no light. I mean, I remember George. Do you remember George Cole? George Cole was the General Secretary of the Illuminating Engineering Society, and he said he would never publish a paper on sunlight. I mean, that daylight was boring, but sunlight was so out of so remote from illuminating engineering that he wasn't interested in it at all. Well, we have to break through. I mean,
the fact that it's now called the Society of Light and Lighting shows that it's come a long way, doesn't it?
oh yes, it's come a long way.
Yeah.
Yes, I mean, yes, it's come a long way, and I think, well, it's come a long way, and this is mainly due to BRE, but I think Pilkington's did have a part to play in this.
I bet you're delighted to know that this has become, for many years, the standard way of calculating.
Well, I don't know what it is, but
I mean, nowadays there's all kinds of software, but for many years this was the way to do it.
I see. Well, not everybody would have said that. No, not everybody would have said that.
Well, certainly on courses I've been on.
That's interesting.
Yeah, this was the way to do it.
Oh, good. Oh, well, that's nice. But
so what was the opposition? Was it just because people wanted to sell more artificial light, or
Oh,
they
I think
didn't really understand?
they didn't understand it and want to understand. I mean, look, there's no doubt. I mean, if you see, the IES was in effect run by the lighting manufacturers. I mean, there's no, with a contribution from BRE, but essentially it was. I mean, that was. Those were the people who did it, and I mean, Pilkington's had no part in it at all. I mean, it was and Pilkington's and Chance Brothers and so forth.
So you must be pleased to know that one of the first things you do when you're lighting a building is just to consider the daylight and what angle the whole building makes with the sun before you do anything, which is rather good, isn't it?
Well, yes, but I mean, yes, but I mean that's the logical way to. I mean, there isn't some other way to design a building. You either ignore lighting entirely.
They didn't do that at all in the past. They just ignored the daylight.
Well, I don't know. It was interesting. So I talked about the architects who never had any training in daylight and so forth. See, what they used to talk about was aspect and prospect, and they talked about north light and south light and east light and west light. I mean, they were alert to orientation and so forth. I mean, way back. I mean, I guess in the 19th century even. I mean, this was all definitely part of architectural thinking.
But back in the 60s, 70s, and 80s, when you considered the lighting in a building, very often it was straight to the artificial.
Oh yes,
but now again, it's not. The daylight is very much the first thing, then this.
Well, good. Well, this is partly because lighting education now has more to do with schools of architecture. I mean, in those days, a lighting engineer to get trained wouldn't go to the Bartlett. That's the last place that, I mean, absolutely, that was the last place that any engineer would go to. I mean, you went to South Bank Polytechnic, what was it called? Borough Polytechnic in those days, if you were in London, or Regent Street Polytechnic.
So would you say that the culmination has been this paper a sequence?
I don't. Well, it's interesting. I stumbled on the idea of average daylight factor. Which isn't a particularly surprising thing. I mean, if you've been brought up in electric lighting and you're used to the Lumen method and you deal with average illuminance, and then suddenly, when you come to windows, you don't think about average illuminance at all. That's nonsense.
Oh,
I mean. And it's true. Well, for example, when I wrote, have you seen a book called Principles of Natural Lighting?
Mm-hmm.
Well, that uses average daylight factors from roof lights and uses utilization factors. I mean, the whole, and that was surely a logical thing to do. But it hadn't been done before. I mean, it was. We did it at Pilkington's.
And you also talk about not being able to see the skyline.
Yes, well, that's interesting. The night skyline was considered quite important in the 1930s, and then it was forgotten about. I don't know why it was forgotten about, because it's very. I mean, it actually is a handy
yes.
Criterion. And so I did revive that, but it wasn't original. It was simply...
Well, it's if you like, you reintroduced it.
Yes, that's right. Yes, that's right. But I reintroduced it, but I don't take any credit for it. It's such a simple and obvious thing, isn't it?
But in all the post-war stuff, you were like the first to talk about it again, I would say.
I think probably that's right. I think that's probably right. I mean, I don't know why. I just don't know.
And there's all kinds of modelling now to do with buildings that are other buildings that are in the way of the daylight. What do you feel about those advances? Well,
that was. I mean, there was a lot of work on that in by BRE in the 1950s, I guess. Yes, Bill Allen was one of the people, and they produced daylight indicators and so forth.
And the recent work of John Dalevich and others, it's all becoming very up to date and inclusive.
That's great. Yes, I've always been concerned with daylight, with the design, what an architect, I mean, the decisions which an architect has to make, and the stage at which architects make decisions about daylight is very early. I mean, whether you like it or not, is very early on in the design. Even if you make those decisions by default, you're still... I mean, the way you put a building on the site and the way it relates to other buildings, I mean, it necessarily has to be at an early stage of design. You can't say, oh, I'll decide later where to put the building. And so a designer needs to know at that stage, at that very early stage, what are the daylight implications, what are the heating implications. If there are acoustic implications, what are the acoustic implications? What are the wind environment implications? I mean, all those things, if you don't think about them at that stage, it's a bit late to start thinking about them later on.
But the inclusion of daylight has really come to the fore now, and I think what really helped were these mnemonic ways of starting.
Oh, good. Oh, well, I'm glad.
And it's progressed.
Yes, I think it has moved, yes.
And there were other things you did, like grease spots, and tell us about those.
Well, again, this was a student thing, and well, I mean, it's a very simple thing. If you have a grease spot on a sheet of paper, then when the grease spot on both sides either disappears or there's no difference, depending on the piece of paper, no difference between them, then you're in the plane of the vector, or rather the vector is in the plane of the piece of paper. Well, that's handy. Yes, you can do it. You can do that. Anybody can do it. Yes, it's not.
And you were talking earlier about these visibility
meter. Yes.
Yeah, and there's many things like that.
That's right. Yes. Well, that's right. They're handy, but they don't constitute design. Whereas this sort of thing and the sequence for window design actually helps somebody to design at the stage when they need that help. That's the...
Yes, yeah. So it just puts you on the right path at the beginning.
Well, that's right, yes.
Yes.
But there's a need for both. I mean, it's not... Yes.
Oh, of course. Yeah. What would you describe as your lighting legacy?
Oh dear.
You've produced so many papers and you've done so much work. And even in our conversation, I've learned other things that I didn't know. What would you say?
Well, I'd hope my legacy was in the students that I taught, and
would you say those practical ways of understanding those nuances that come out of your work? They're not dry, are they? You come away thinking, well, it's a phrase that I can remember. Is that fair?
I hope not. I think what I'd like them to remember is to use their eyes. I mean this is what I get them to do. So, for example, for an average daylight factor, you get a group of students into a room, each in different rooms, and calculate the average daylight factor and measure it, and appreciate. Well, I hope you get the same answer, which on the whole you do. This is so much different from pepper pot diagrams where you don't get the same answer, and unless you've got an overcast day and so forth. But with average daylight factors, even if it isn't an overcast day, you put your light meter against the window and reckon how much light is. Reckon from that how much there is on a horizontal surface on the roof, and express your average illuminance in the room as a fraction, as a percentage of that. And that's what the average daylight factor would be if it was an overcast day. But the important thing is that they have the experience of being in that room, and if the average daylight factor is, say, 4%, that is what an average daylight factor of 4% looks like,
Yeah.
And
it's tangible.
Yes, that's right.
Yeah.
And I'd hope that that's true of everything I taught, that they're conscious of, what it actually feels like to be in a room lit at 200 lux, 400 lux, and so forth, and what are the limitations of that measurement? How it doesn't just depend on the light on a horizontal surface.
It's all the other surfaces
yes,
in
that's
relation.
Right. And that's that I hope is my legacy, which is little enough, but that's what I would want. Yes, that students
Appreciate these.
Appreciate those things, and indeed some do. There's no doubt. I'm still in touch with some of them, and
Oh yeah.